All right, let's dive in. Today, we're going to tell the life story of artificial intelligence. But we're not going to talk about it as just a bunch of code. Think of it more like a character that started out learning to count and has grown into this incredible, world-changing force we're all talking about today.
I mean, just think about that for a second. It's a massive leap, right? We went from a machine that could only do your math homework to one that can compose a symphony or navigate a chaotic city street. So how did that happen? That journey is the story we're unpacking today. It's a story of learning, of some wild breakthroughs, and of AI quite literally stepping out into our world.
You know, every story has a beginning. And for AI, its infancy, its first steps, were all about learning from the world around it. Just like a baby, it needed to be fed. But its food wasn't applesauce, it was data. And not just a little bit. We're talking massive, unbelievable amounts of data.
So what is this data we're talking about? Well, it's pretty much everything. It's every book ever written, every picture you've ever scrolled past online, it's the sound waves in your favorite song, even the temperature readings from a weather sensor. All these raw bits and pieces of our world are the absolute essential fuel that powers the AI learning engine.
Here's the thing, though. An AI can't just read a book or see a photo the way we do. It speaks one language and one language only, math. So it has to translate our entire world into its language. And that process is called embedding. It basically turns words, pixels, and sounds into these really complex sets of numbers, almost like coordinates on a map, that represent their meaning in a way the machine can finally understand.
Now, in the early days, this learning process was really manual. With what we call classic machine learning, we basically had to hold the AI's hand. We'd have to tell it, hey, if you want to find a cat, you need to look for pointy ears and whiskers and a tail. We had to spell out all the important features. But then came deep learning. And this works a whole lot more like a human brain. You just show it a million cat photos, and it figures out for itself what makes a cat a cat. It creates its own features, which was a total game changer.
And that leap into deep learning was kind of like AI's adolescence. This is where it developed its own complex, layered brain, what we call a neural network, and a really powerful new way to learn from its own mistakes.
So how does it actually learn? Well, first, it has to know when it gets something wrong. Let's say we show it a picture of a cat, and it guesses dog. The loss function is what calculates a mistake score. A perfect guess, that gets a score of 0. A really, really bad guess gets a super high score. And the AI's entire goal, its whole reason for being, is to get that mistake score as close to 0 as it possibly can.
Okay, so the AI knows it's screwed up. It got a high score. But why? What part of its thinking led to that mistake? That's where this thing called backpropagation comes in. It's like a detective, tracing the error backward through every single layer of its artificial brain to pinpoint exactly which connections, or neurons, were the ones that led it to the wrong conclusion. And once the AI finds the source of that error, it has to fix it. This part is called gradient descent. And honestly, the best way to picture it is to imagine you're a hiker lost on a foggy mountain, and you need to get to the lowest point in the valley. You can't see anything, right? So what do? You feel the ground with your foot and take one small step in the steepest downward direction. That's exactly what AI does. It makes a tiny adjustment, then another and another, slowly but surely walking downhill to find the lowest possible mistake score.
So AI was getting pretty good at this point. But there was this one aha moment, a single breakthrough that was about to change absolutely everything. This was AI's moment of genius, and it unlocked a whole new level of understanding and capability that we are still riding the wave of today.
And that moment came in 2017. A research paper dropped with this incredibly bold title, Attention is All You Need. And it introduced a new design, a new architecture, called the Transformer. This didn't just improve on the old ideas, it completely rewrote the rules of the game.
So what on earth is attention? Well, look at this sentence. The animal didn't cross the street because it was too tired. How do you know what it is referring to? Your brain just knows. It is the animal, obviously, not the street. Well, before 2017, AI was terrible at this. The attention mechanism was the genius idea that allowed an AI to look at all the other words in a sentence and weigh their importance to understand these crucial relationships. In short, it finally learned where to focus. And that ability to grasp context, that was the secret sauce that unlocked everything from ChatGPT to all the modern generative AI we see now.
This also totally changed how AI reads. The old models, they were like a person reading a book one word at a time. Super slow, and by the time they got to the end of a long paragraph, they'd pretty much forgotten what the beginning was about. Transformers, on the other hand, read the entire sentence or the whole document,
all at once. They process it in parallel. This isn't just blazing fast, it lets the AI see the whole picture and understand the full context instantly. With this new power of transformers, AI entered its next big phase, maturity. It went from being just a bunch of different specialized tools to becoming a massive, general-purpose platform that we now call the foundation model. A foundation model is, well, it's pretty much what it sounds like. It's this huge, powerful, base-level AI that has learned from a giant slice of the internet. The best way to think about it is less like a finished product and more like a universal engine. You can take this one engine and adapt it or fine-tune it for thousands of different jobs, whether it's writing legal contracts or helping to diagnose diseases.
And as these models got bigger and bigger, something really weird and fascinating started to happen. They started developing skills they were never trained to do. We call this emergence. They just learned how to reason. They started solving logic puzzles and writing computer code all on their own. And this led to something called homogenization, where now, instead of building a totally new AI for every single problem, we usually just start with one of these few giant, powerful models.
At the same time this was all happening, AI basically grew new senses. It wasn't just about text anymore. Now multimodal AI can see, hear, and read, all at once. So imagine a doctor giving an AI an MRI scan, their own handwritten notes, and a patient's lab results. The AI can process all of it together, drawing these incredible connections between the different types of information to get a much deeper, more complete understanding of this situation.
Okay, so this brings us to the final chapter of our story. For now, with this deep understanding of our world, AI is moving beyond just spitting out answers. It's starting to take action. It's getting a job.
And this is the huge difference between a simple chatbot and what we call an AI agent. A chatbot is reactive. You ask a question, it gives you an answer. It's basically a search engine you can talk to. An agentic AI, though, is proactive. You give it a goal, and it works on its own to achieve it. It's not just an encyclopedia anymore, it's more like a digital employee. So how does it pull this off? It follows this really simple but incredibly powerful loop. First, you give it a big goal, like plan my vacation to Italy. It'll break that down into a logical step-by-step plan. Then it actually uses tools to get the job done, like browsing websites for flights or booking a hotel through an API, which is just a digital doorway that lets different programs talk to each other. And here's the most important part. If it hits a roadblock, like a flight is sold out, it can self-correct and try a totally different approach. This is all amazing, but it's still happening behind a screen, right? The final, and maybe the most profound step in AI's life story is its leap out of the digital world and into our physical reality. And this isn't science fiction, it's happening right now. We're seeing humanoid robots that can learn to do factory work just by watching a human do it. We have autonomous cars navigating the absolute chaos of city streets. And these are not just pre-programmed robots running on a track. They are physical bodies with AI brains that can see, understand, and adapt to the messy, unpredictable physics of the real world. And that leaves us with one last, really big thought to chew on. Over this whole journey, AI has learned our language, and it's even starting to learn our logic. The next great frontier is for it to truly understand and master our physical world, the world of gravity and friction and cause and effect. What happens then? Well, that's the next chapter in this biography, and it's a chapter that all of us are going to be a part of.